I am John and this is my video about Git. So in this video I'm going to be giving a brief overview of the Git version control system. I'm going to start by describing a typical scenario of how we might use Git on a day-to-day basis. And then I'm going to be drilling deeper into making changes locally, branching, commits and the staging area, how we might interact with a remote repository, and then giving some real-world examples of developers using Git and some of the actions they might perform in their day-to-day job. So Git is a distributed version control system that we use to hold, manage, change, integrate and deploy our code from. So this is widely used, very popular with developers, and one of the key toolings of many enterprise organizations for developing their applications. And it allows developers to work on a project as individuals, but part of a team without stepping on the toes of other team members or stepping on the toes of production. And in its nature, it's decentralized, and this is a distinction between Git and other version control systems that are out there. When we clone a repository to our local PC and we're working on code changes, we're actually working on a complete local copy of the code. We're not affecting the central copy held using our software development CI/CD tooling where our repository is held. So that is the distinction with Git. So to give an example of a typical scenario, these steps run in chronological order, and this is what we might do with Git. So first we would create a remote repository in GitHub, Azure DevOps, GitLab, etc. So there's many other tools out there that hold Git repositories and are compatible with Git repositories. So these are just some examples. And these are examples of CI/CD tooling. So there's a lot of capabilities around these tools that allow us to integrate code that's held in our repositories and then deploy to production, running unit tests, building the application. So typically these hold Git repositories, and throughout this video I'll refer to these as the remote repository. So then what we might do is clone the remote repository to our local PC, and that will download a complete copy. In this example, we've created a new repository, so it's going to be empty at that stage, but we can clone it to our PC, and we could do this for an existing repository as well. So we clone it to our PC, we can then create a branch and then switch to it. So Git repositories typically have a main or a master branch, and this contains the production-ready deployable code. And what we can do when we want to make changes is create new branches that are a copy of the main branch, and then we can make changes in that branch without affecting the production main or master branch. Another developer on the team can then create their own branch, and another developer can create theirs, and unless you switch to their branch, you're not going to see the changes that they're working on. We would then make code changes in our branch. We'd add those changes to the staging area, and I'm going to get a bit more into the staging area and the concepts around that, but ultimately this is an intermediary area where we can stage our changes ready to commit. We then commit the changes from the staging area, and then we can push the changes back to the remote repository. So ultimately, through these steps, we start with a blank repository held in the CI/CD tooling. We cloned it locally, made changes, and then pushed our changes back. So the first area I want to go deeper into is making changes locally. So as I mentioned, a remote repository can be created on GitHub, Azure DevOps, or GitLab, or any other tooling that holds our repositories, and then cloned locally. So that's one option. Another option is to create a local repository by initializing it locally. So if the repository doesn't exist in our tooling yet, the remote repository, we can actually initialize the repository locally. So I've got some example commands here. The first one is the git clone. So git is the command line tool that allows you to interact with Git on your local PC. And the git clone command with authentication and the path to where your Git repository is held, which is typically going to be a URL. We can clone that repository and all of its branches and commit history and stuff like that down to our local PC. Alternatively, if we're not cloning an existing repository, we can do git init, and this initializes the repository, a new repository on our local PC. If we use the initialize command to create the repository on our local PC, we need to create the remote repository separately, and then we can do the git remote add origin and then the repository URL, and this will create a link between our local repository that we initialize and the remote repository. This command doesn't push any changes or synchronize the repos or anything like that. It just creates a link. We can then run another command to push our code to the remote repository, which I'm going to talk about in a separate slide. So then we've got branching, and as I mentioned, the main or master branch typically holds the production ready code, and this is the code that's been through all of our CI/CD tooling. It's been tested, it's been approved by a senior developer, for example, and it's been allowed to be merged with the main branch. So branches act as separate lines of development that do not interfere with each other. So from our main and master branch, if I'm working on a new feature, I can create a new branch, I can work in that branch. My colleague can then create his own branch if he's working on code changes as well. And we won't be stepping on each other's toes because we're working independently. Later down the line, we will be merging our changes into the main branch, and there'll be a procedure around that, around all the testing and whatever process our team has defined. But that comes later in the process. At this point, we won't be stepping on each other's toes or affecting the production main or master branch either. So branches are typically merged using defined procedures after a push to the remote repository. So we typically make all of our changes, and when we're ready, we push to the remote repository, and then on the remote repository, our branch will be there. It won't be in the main branch yet, and then we'll have all of our CI/CD tooling and the process we've defined to get that code closer to production. So then we've got some commands in relation to branching. We've got git branch, and this just creates a new branch. So if we've got the repository cloned to our local PC, we've got all the branches there that currently exist. We can create a new one by running git branch and then the name of the branch. We then got git checkout, and this allows us to switch to another branch. So we'll be able to see, if we're using Visual Studio Code as an example, that's got integrated Git functionality, and we can see all of the branches that exist, and we can switch to one. So we could create a new branch using git branch, and then we could switch to that branch using git checkout. But then there's also another command, git checkout, with the argument b and then the branch name. And what this does is the previous two commands, git branch and git checkout, in one. It will create the branch and then it will switch to it immediately. So the next area is commit and staging. So staging acts as an intermediary area containing files to be included in the next commit. So carrying on from the previous slide, we've created a new branch, we switched into the branch, we can now make our changes without stepping on anyone else's toes, and it's just on our local PC at this point. So when we're ready and we're happy with our code changes, we need to stage them. And this adds them to right before we commit and we're saying that we're ready for these changes to go, we can stage the files either one by one or all together. So if we've changed, for example, 10 files, we can decide, okay, we're going to stage all 10 files, and then we're going to commit and we're going to push it all together to the remote branch. Or We can choose to stage maybe some of the files if we only want to send some of the code at this point. And this allows us to break down files into multiple commits for whatever reason we might want to do that. We might find that we actually only want to do one change or apply these changes more piecemeal instead of doing them all in one. So then we've got the commands. So we've got git add file or directory, and this adds individual files or directories into the staging area ready for a commit. We then got git add dot, and that is an alternative to the first command. It just adds all changes into the staging area ready for the commit. We then have commit git commit -m, and this will commit all of those changes that we've added to our staging area. Or we can run git commit -a-m and then the message, and this will add all of the changes that we've made to the staging area and commit them. So we wouldn't need to run git add if we run git commit -a-m. So then we have interactions with the remote repository. So when we've done committing our changes and they're ready to be uploaded to the remote repository, we can run git push origin and the branch name, and this will push the changes, committed changes, locally to the remote repository. We then have git fetch, and this is for when there has been changes to the remote repository that we would like to see on our local machine. So after we've done that initial pull or clone and we've got the repository on our PC, other developers on our team are going to be making changes and pushing new things to the remote repository and adding new branches. And what this does, git fetch, is it downloads any new branches, git history, but it doesn't merge the code. So if someone's changed something in my branch on the remote repository, git fetch won't download those changes and merge them into my local repository. That is what git pull does. So if you run git pull, it will download and merge any changes that have been made on the remote repository as well. So git pull is the equivalent of git fetch and git merge. So now let's look at some examples of developers interacting with Git and what they might do in their typical day-to-day scenarios. So we've got person A, and person A is working to create a new feature of an existing application. They run git clone with the authentication and the URL, and this creates a local copy of the repository on their PC. They do git checkout -b feature /new feature. So this will create a new branch called feature /new feature, and then it will switch into that branch immediately. They then make all of their code changes in that branch. They run git add dot, and this will then add all of the changes that they made into the staging area. They then run git commit -m, and then they put a comment that reflects the changes that they've made. They then do git push origin feature new feature, and this will push that new branch with the changes to the remote repository. And as I mentioned before, this won't affect the production ready main or master branch because there is a later process, typically on the CI/CD tooling, to do testing and pull requests and have someone approve and review the code changes. So git push won't affect the main branch. Then we've got person B, and person B is reviewing the changes that person A made and the new feature that they're adding. And they do git fetch origin to download the repository to their PC, and then they do git checkout to switch into that branch that person A had made. They then review the code and they can provide feedback. Finally, we've got person C, and person C is doing effectively the same thing as person A, but instead they're working on a bug fix. So they run git checkout -b bug fix /user image loading, which is the issue they're resolving. They make all their changes. They run git add dot again to stage all of the changes in one. They then commit all those changes using git commit -m, and then they do a git push to push that new branch that they've created. That concludes my presentation on Git. Thank you for watching.